Hello dear students, welcome back to the video classes. Today again we are going to start with functions, types of functions and their problems. This is the 8th lecture on the topic relation and functions. Let me begin with the problems on the types of functions. In last video already we have seen the types of functions and their definitions. Today let me begin with the examples on the types of functions. Let me begin with the exercise 1.2. The first example, show that the function f from r star to r star defined by f of x is equal to 1 by x is 1 1 and onto, where r star is the set of all non-zero real numbers. My dear students, in this function the set of domain is r star, that is set of non-zero real numbers. The 0 is not included in the set of real number, and the codomain is also the set of non-zero real numbers. Therefore the domain and codomain are both the same sets which is containing the non-zero real numbers. The function is defined f of x is equal to 1 by x, which is called as a rational function. This rational function we have to show that which is 1 and onto. Let me begin with the solution of this problem. Let r star is the set of all non-zero real numbers. F from r star to r star defined by f of x is equal to 1 by x. Let me show that this is 1 1 and onto. Let me begin with 1 1 function. As per the definition of the 1 1 function, we have seen that let me take any two elements belongs to the domain set. Let x1 comma x2 belongs to r star. Consider f of x1 is equal to f of x2. As we know by the definition of the function f of x is equal to 1 by x, therefore f of x1 will be equal to 1 by x1. Therefore f of x1 is equal to 1 by x1 and f of x2 is equal to 1 by x2. By cross multiplication, the denominators on both the sides, we get x1 is equal to x2. We have started with x1, f of x1 is equal to x2. We are concluding with x1 is equal to x2. Therefore, such functions are called 1 1 functions. Now, let me show the function is an onto. Let me begin with onto function. To show that the function is an onto, let me start the elements from the codomain set. In this problem, the domain and codomain sets are same. For all y belongs to r star, which is a codomain, there exists its pre-image x belongs to r star. X belongs to the domain and y belongs to the codomain, such that y is equal to f of x. Now y is equal to, our f of x is nothing but 1 by x. In this case or in this type, we are able to solve for x. We are supposed to solve for x. By cross multiplication, we get x is equal to 1 by y belongs to r star. For any value of y, there is a value of x which is belongs to the domain r star. For all the values of y, there is a x value which is belongs to the domain r star. That's why we have tried belongs to r star. Therefore, in such case, f is an onto. Let me take one example over here. If y is 1, which is belongs to r star, then 1 by 1 is 1. X is also equal to 1, which is there in a domain r star. If I take y belongs to the r star, that is 2 belongs to r star, then the value of x will be equals to 1 by 2. That is also there in the domain r star. For all the values of y, there is its pre-image in a domain. Such functions are called onto function. Therefore, the given function is both 1 1 and onto. Let me begin with the second question. Check the injectivity and surjectivity. My dear students, the another name for the 1 1 function is injective and onto function is surjective. In this problem also we are going to show or we have to check the given functions are injective or surjective or one and onto of the following functions. The first function is given to you f from n to n, that is set of domain and codomain are the set of natural numbers, which is given by f of x is equal to x square. Let me begin with the solution of this problem. Let n be the set of natural numbers, that is f from n to n, given by f of x is equal to x square. We have to show that this function is, we have to check that this function is 1 and onto or not, whether it is injective and surjective or not. Let me begin with 1 function. To begin with 1, let me start x1 comma x2 is belongs to the domain. Consider f of x1 is equal to f of x2. Our conclusion is to prove that x1 is equal to x2. As we know, f of x is nothing but x square. Therefore, f of x1 will be equal to x1 square. Dear students, you can look at here. Our f of x is nothing but x square. Then you replace f of x as x1. Then f of x1 becomes x1 square. And f of x2 will be, it is x2 square. Therefore, we are replacing for f of x1 as x1 square and f of x2 as x2 square. Now let me solve for x1 and x2. x1 square is equal to x2 square. Then x1 is be equal to plus or minus x2. Since the domain is our set of natural number, it has only positive values of n. Therefore, x1 is equal to x2. We have started with f of x1 is equal to f of x2. We have concluded that x1 is equal to x2. Therefore, the given function is a 1 function. Function. As we know that we have to start the element from the codomain set. Our codomain set is also a set of natural number. For all y belongs to n, there exists an x belongs to the n, that is from the domain, such that y is equal to f of x. This implies that y is equal to x square. In this step, our intention is to find the solution for x. Therefore, x is equal to plus or minus y. As you know that if x square is equal to 4, then x will be equal to plus or minus square root 4. That is, x will be equal to plus or minus 2. Likewise, we can solve for if x square is equal to y, then x will be equal to plus or minus root y. Therefore, we can see here y is equal to x square. Therefore, x is equal to plus or minus root y. This implies that x is equal to plus of root y. Because the domain and codomain are the natural numbers, there is no negative values of x and y. Therefore, I take only positive values of x. Therefore, x is equal to plus of root y. But this x is not belongs to n. For all values of y, there is no pre-image in the domain. Suppose if I take y is 2, root 2 is the value of x. For 2, there is no pre-image root 2 in the set of natural number. That's why this value of x is not belongs to n. Therefore, our f is not onto. Therefore, the given function is only 1 but not onto. It is only injective but not surjective. Let me take the third example from the same question. Once again, we have to check the injectivity and surjectivity of the given problem. The function is same as defined in the previous problem, but the domain and codomain in these problems are real numbers. Set of real numbers is the domain and set of real numbers is again a codomain. Both are containing zeros. In the previous question, the same function was defined, but the domain and codomain were the set of natural numbers. Let me begin with R be the set of all real numbers, defined by f from R to R, given by f of x is equal to x square. Let me begin it 1. Let for all x1 comma x2 belongs to R, consider f of x1 is equal to f of x2. This implies that x1 square is equal to x2 square. Therefore, x1 is equal to plus or minus x2. Therefore, in this case, you can see that we have the two values of x1. That is, one is x1 is equal to plus x2 and another is x1 is equal to minus x2. Since our domain is a set of real numbers, it has both positive as well as what it is negatively. Therefore, x1 has two images. Therefore, here we can say that x1 has two images in R, therefore f is not 1 function. In previous question, the domain was set of natural number, therefore only positive values of x1 were taken, therefore there was an x1 is equal to x2. But in this case, the domain and codomain are real numbers. It has two answers for two images for x1. Hence, f is not 1. Let me begin for onto. For all y belongs to R, there exists x belongs to R such that y is equal to f of x. This implies y is equal to x square. Therefore, let me solve this x. In this step, we get plus or minus root of y, which is not belongs to R. Because for all values of y, there is no pre-image of x in domain set R. If I take y as -1, root of -1 is a complex number. That is, we have seen that if root of negative numbers are always a complex number, but the given domain is our set of natural number, real number, which is not belongs to R. Therefore, this function is not an onto function, because for some values of y, there is no pre-image in a domain. Therefore, like the root of -1, root of -2, root of -1/2, these are not there in the set of domain R. That's why for any value, some values of y, there is no pre-image in R. Therefore, the function is not onto. Therefore, this function is neither 1 nor onto. Let me take one more simple example. A set is given for us. Let A is equal to 1, 2, 3, B is equal to 4, 5, 6, 7, and f is a function defined from 1, 4, 2, 5, 3, 6. Be a function from A to B. Show that f is 1, 1. Here the function is defined. It is given for us. There are the two non-empty sets. Okay, there is a mapping f between these two. The elements of the domain are 1, 2, 3. This is the set A. The another set is B, which is containing the elements 4, 5, 6 and 7. Here it is given that the image of 1 is 4. The image of 1 is 4. The image of 2 is 5. The image of 3 is not in the codomain, that is 7, which is there in the codomain. Therefore, every element of the domain have the different image in codomain. Therefore, this function is called an 1 function. Let me begin here. F is defined. The image of 1 is 4. The image of 2 is 5. The image of 3 is 6. The domain have the different images in a codomain. That is, f of 1 is 4, f of 2 is 5, and f of 3 is 6. Different elements of the domain have the different images in codomain under f. Therefore, f is said to be 1, 1. Therefore, this type of questions will be asked in the examination for 2 marks. Therefore, such questions will be expected in the examination. In the previous type of questions were expected, this type of questions were expected in the examination for 3 marks. These are the questions for 3 or 2 mark questions. Dear students, I hope you have understood today's lecture. If you have any queries, please contact the given below number. Thank you. Stay home, stay safe.